Awesome. Thanks, Rory. Thanks for that. So I have about 300 slides for you. Like I said, not really, but we're just going to go through a bit of presentation here, and then Basler is going to take over. And most of the time, hopefully, we'll spend with demonstration. So why large language models in general? If we look at systems, you work with enterprise systems today. You have processes around it. You want to do certain things with the data. Data can be structured, unstructured, but data is specific in an entire context of itself, and it doesn't speak natural language. You cannot start to converse with it in natural language either. So it's a little bit more rigid when it comes to that. It does lack a bit of sentiment sometimes, but it definitely has context and a lot of it, right? So how can we bring those two things together? It's kind of important, and also makes better experience. So generating content can be costly. It can be hard in terms of how you create new applications, bring them together. All of that needs a lot of love and care. And when we build application, they take time. They just don't happen over just a couple of minutes, right? Maybe these days, with some vibe coding, if you have it, might be able to do something out of it. But yes, creating systems is not that simple. Users needs to be kept in mind, etc. But then if we have the possibility to add data to something like a large language model, and be able to ask questions, interesting questions, from pure natural language, it kind of makes things a bit more interesting for us. Another aspect is also the rapid data growth, right? So there's a lot of data growth that happens when it comes to IoT systems, edge devices, even from systems where we collect metrics, observation data, etc., etc. There's a lot of data growth these days, and data is interesting, right? So why not make use of it, and why not use something like which can actually process on natural language and give us some meaningful insights into the data we have. So models, artificial intelligence kind of makes sense. Another thing is obviously rising expectations. Like today, you, for example, call for something that went wrong. It's a support ticket. Customer, let's say you created a support ticket. You had an airline flight. You wanted to reschedule, etc. And it gets harder and harder because their systems are rigid, processes are rigid. You don't get a lot a lot of information out of it. Another example is like if you're searching your bank or your transactions, again, while searching them, you need to go through a rigid system which just can has filters, etc. What if you were just able to quickly search it through natural language, etc. as well? So there's some interesting use cases that you might want to look at, right? So let's take a look at quickly around what the journey of large language models has been. If you have taken a course in expert system back in the days, then you've been here for a long time, right? They were quite hard. They use a lot of data that was authored with rules, etc., but that was very rigid. It was not so easy to train systems back then. But then machine learning, deep learning came in there, and that kind of changed the way how we program the neurons or tensors or whatever you want to call them, and can actually have learning that was supervised or unsupervised. So basically train the system in a way that it can effectively make certain decisions and learn from them as it went forward as well. And in the recent years, what we've seen is the foundational models, which basically come out of a lot of data, labeling that data, putting that data into these systems, and creating something which is interesting for us from a natural language perspective as well. The other aspects of large language model is what we've heard about. For example, is the transformer architecture, and that kind of brings it to a more interesting area, because systems like GPT-3, I believe, was trained around 300 billion um, you know websites, etc., and it of words, and that's a lot of data. Common crawl data set is even bigger, and all of those data sets brought together give you a lot of information, to basically use things like we can do summarization, generate specific text, and some of the interesting cases like generating poetry, etc., stories. But how about we can use them to actually do more deduction out of the systems, and create more meaningful content as well. The way large language model works, they use tokens, and tokens sort of kind of describe describe the different layers of how large language models are trained. For example, if we were taking a simple word as unpredictability, you would see that it could actually be tokenized into three different sort of arrays as well. And that is important because that's how the large language model reacts. And sometimes we might not get the answer when we look at a RAG solution, and we're going to demo some of the RAG solution today as well. So things could actually not make sense, but then they also make sense when you bring them into a larger chunk, etc. All of that plays around with these numeric values that you see. Another thing that you see is when you send a request to a large language model, it is also going through tokens and coming back in tokens as well. So it's also a mechanism of how you're consuming the large language model, or maybe in terms of cost and pricing as well. Um, Another aspect of large language models is they're not usually very accurate. So do not mix accuracy with truth. And here, for example, you see an amazing photograph, but that photograph is not completely correct, right? And this can happen. And large language models have the problem that they will hallucinate when they don't have the data that you actually are using. So this can get tricky. And how do we actually work with that is also interesting, and something to work with. And that's where approaches like RAG or some of those other approaches come, but they do not fulfill that. However, there are things like guardrails or privacy, etc. But just putting some thought there for you, that do not think this is a silver bullet that's going to give you an answer for everything. It's going to fail. And the most important thing is, when it fails, how do you deal with it? The other thing is, that truth is obviously is not continuous. We don't say things like, "Hey, we saved 6.5 lives." We don't save 6.5 lives. We save 6 lives or 7 lives. And I think that's the important differentiation between how large language model works in terms of how the real life works as well. And that's also an important factor to think about when we start to look at large language models. A lot of words, even I said a lot of these words in maybe a speed record time here, but basically, when we look at large language models and when we start to take our first steps, we would see this, that there's a lot of words like embeddings, like attenuation, transformers, etc. All of these things and all these different models that are in there, that can confuse you. So hopefully from this session, and from the source, etc., that we share with you, you're able to sort of get started and start to learn about large language models in a much more easier way. Um, the tool that we also had in our title was LangChain4j, and LangChain4j gives us the possibility to integrate with large language models, gives us the possibility to do RAG tools. If you want to write MCP, if you've heard about Model Context Protocol recently, we can use LangChain4j as well. So it's a really good and nice framework for us to work in the Java ecosystem to integrate with large language models. And at this point, I'm gonna take a little pause, and I'm gonna let Basler share his screen so he can demonstrate what we are looking at, and how can we actually create smart applications in Java using large language models. So Basler, over to you.
Balsar, I am so sorry. You are on mute. I am so sorry. We still cannot hear you.
Can you hear me
There
now?
we go. Thank you.
I'm so sorry again. All right, moving on. So we have prepared plenty of demos for this tool with the LangChain4j and the Jakarta EE, but due to time constraint, obviously we'll not be able to show you all the demo. So we're gonna pick a few, and this is how we started. Basically, there is a Start Jakarta EE project over here where you can basically choose your favorite platforms, versions, and Java environment, and then you can click over here, the generate button, it basically give you a structure, and then on that structure you can put your own code. So that's how we started, and that's how we build our demo. So this is the first one. Basically over here, as you can see, in the POM we have some dependency, mostly related to Jakarta EE, and then we have these two tools, which is LangChain4j. One is for OpenAI and one is for the core. So these are the two dependencies we're dependent on, and all the communications with the model, for example, OpenAI or some other models that are out there, it abstract everything over here. So as a developer, we can write something like this. So we have a, over here, we have a class called OpenAI chat model. It's basically an abstraction, and then there is a builder pattern. And using this builder pattern, we can provide additional parameters, which is you can check later. But this is how we basically create a chat model, and then we can send text to it. So over here, as you can see, chat model, there is a method called generated. We are sending messages, and it will respond the messages. So in this project, we have a WebSocket basically that's talk to the UI, and we have a nice UI over here that we can show you. So what it does is basically when we write something, it communicates with the WebSocket and send the message to that particular class that I showed you, right? And then it send back to us. That's all it does. So it's a little UI that we wanted to show you. So on top of that, we basically started building some other interesting aspect of this LangChain. For example, by default, all LLMs are fire and forget. It use fire and forget strategy. It doesn't have memory, right? But when you are discussing with having a conversation with the user, you need to preserve the context of previous conversation. Otherwise, the LLM will not have the context to respond properly. So all those things are added on top of one by one. So we have a 9-step project over here that we're going to share with you, the Git repository, but we'll probably not show you all, obviously time constraint. So there also we can customize the prompt. For example, you can provide the system messages. We have a few over here. For example, if we want to use a prompt like that, we can do something like this. It's called AI services. We can provide our specific prompt, so the idea is we can specify how we want to get response, and then we can send a message that this is what we want. So if we want to specify how part, we can specify using this prompt. As you can see, it's simple, and we have just two annotation over here: system message and then user message, which is going to pass through the users. So all of those things, but I'm also going to keep this particular one, and I'm going to directly go ahead and start with another interesting tool idea, which is called tool. For example, if I go over here, and if I ask the chat, this is a chat interface, right? If I ask like, hey, do you know the latest stock exchange information, it will probably not be able to answer that, because as you can see, it says I'm unable to provide the real-time stock access information or financial data. So, but what if we want to have those things? Something like, let's say I want to browse a certain website. For example, if I ask to browse my personal website, which is postblu.ca, by default LLM would probably not be able to do it, but we can add some sort of function calling on top of it, and it can do that. So that's what I'm going to show you, how we can simplify that. As you can see, it's returned that I have written this article. That was my last article. So how did we accomplish that? We have a tool over here. This is pretty simple. We can just specify a annotation over here, which is tool, and we can provide the description, what is tool supposed to do, and extract the information, and we can put our information logic over here. And how do we put this to our LangChain service? So I already showed you. We can create a chat model. using this builder button, and then over here we have another abstraction which is called AI services, and over there we can provide all these tools that we want to use. For example, over here I have 3 tools. One is this web tools that I already showed you, and the other one is a Java compiler. So basically what it does is it can take the Java source code and then compile it, and then run it and share the output. So this is I wanted to do something fun. So that's the tool that I used over here. As you can see, I specified the tool over here and provided the context. For example, execute the provided bytecode directory. So if I provide a bytecode directory, it can extract this information and compile it. And also there is another one which is Java P command. You can disassemble a Java code using this. So I'm not gonna explain all these codes. You can see the code from the repository which I'm gonna show you. But let's show you a demo quickly. So what I'm gonna do is over here, I'm going to write just, hey, can you write a simple sorting algorithm with Java? And let's see if it can. It's fairly easy. It can, in fact, write the Java code. But the challenging part is if you ask our Chat GPT website and you put a source code there and say, and if you ask it to compile it, it will not be able to compile it. But this tool with this supports, we can do that. So I can ask it, hey, can you compile it and run it? And it can I can show the logs over here. So what's it's doing over here. As you can see, it received the message and it's doing all this work. And let's see if it can. It takes a bit of time because it parses this information and compile it and then run it. So let's see if it can. I'll wait for a second. If it cannot, then I'll move on. Okay, so there is some issue over here, but trust me, it works. I in fact tried a few minutes ago. So moving on. So that's one part, and so there is some exception over here that happens, but I'm going to show you a different one which involves tools and Sharp mentioned about RAG, which is retrieval augmented generations. That also I'm going to show you quickly. So to do that, I need to run a separate project, which is this. So running would take a bit of time. So while it's running, I'm going to show you the UI. So the UI looks like this. As you can see, it's a shop. It's a bookstore, right? It has lots of books, and when I'm a user, sometimes I need to find a book, but I probably don't know the name of the book, or probably don't know the author of the book. So how do I find that? And what I can do is over here, I can chat through this. So it's still running. It will take a second, I think. So let's see it. Okay, it's still running. Hopefully it's ready now. Okay, it's ready. All right. So over here, what I can do is I can ask, hey, do you have any books on modern concurrency? Something like that. Hey, do you have any books on modern concurrency? Let's see what it returns. I can obviously full screen and discuss over here. And it's found 2 books. So next step is I want to add this book to my cart, obviously, right? So I can basically tell them in my natural language, hey, can you add this book to cart so that I can buy, right? And as you can see, it added these books, both of them, to the cart. And let's see what it says. Could you please specify which book would you like to add to your cart? So it's basically asking me questions. I can say I want to add the second one, which is in a natural languages. So let's see how it does. As you can see, it says I've successfully added modern concurrency in Java. and I can see over here it's already added in the cart. And as you can see over here, it's 29 in stock. So initially it was 30. Now that I have added in my cart, it removes one from the cart. So how do we do all of those things using in LLMs? So that's what I'm going to show you in the code. It's pretty simple. I'm going to skip the web logic, and Jakarta EE part. I'm going to assume that this is something those who are, Jakarta EE developers already knows. But if you don't know, you can just, later read the source code and figure it out. So over here we have a called Bookstore services, and this is a pretty simple Java classes, right? But all the method has a tool annotation over here. So as you can see, it has a tool. It has also a tool, over here. It searched books by category. This one is basically searched by title or author. If I provide a title or authors, it will find that books from the database and provided me. So these are the so the idea with this tool basically is LLM has context. It can does a lot of interesting things, but if we want to integrate our local business logic, our specific business logic, we can take this advantage of tools. That's a basically abstracted away by the LangChain4j. So I think I'm pretty much out of time. But also there is a RAG part, which is basically we have certain documentations, for example, general information about this store return policy, shipping policy, right? LLM are not supposed to know this. These are the internal information. But if user asks those information, how do we share them? So this is what actually it does. If I ask over here, what is the return policy? So it will be able to um, um, give those information over here. So how does it work? It basically over here we have a RAG ingester. It's pretty simple. It's load all this information from the file and it ingests and it embeds. For right now, we are using a in-memory embedded store, but we can also use database over here. So that's all the demo I had within this time. But if we want to learn more about this project, we are building it. We have like tons of examples over here. It's an 8-step, 9-step project. So both feel free to go to this repository and clone it and try it yourself.
Thank you so much. It was a incredible demo, and you put the oomph and the hype back in Jakarta EE, because now people can go and they can modernize it and they can make it like the Gartner hype cycle there right at the top there, along with everyone else. And we've got a lot of other speakers to speak on AI. So my question to you is Jakarta EE your first choice now for an LLM? In your experience, and this is a hard question here, would you go straight into Jakarta EE, or in your experience, were you kind of like, maybe it can't do it as well?
I mean, Jakarta EE is really an important technology, and many of the other technology are built on top of the idea of Jakarta EE, all the Jakarta EE specifications. So, as a Jakarta EE ambassadors, I personally like to work with Jakarta EE. Yeah, why not?
Well, ironically, we have our next speaker who actually is going to speak on AI also. And then maybe if Dan, if you were there, you can just give us a nice segue from your talk. I want to thank you. And I'm not trying to butcher your name, Balzer and Shaf, for the incredible talk there. And Dan, yeah, so you're leading on from the first talk here, and we're going to bring you on here, and you're going to be speaking on AI for Java developers, which I'm a Java developer. I like AI, and actually, I think I've got a few certifications in Jakarta EE. I love those books that you had there also, though. So I want to introduce Dan, and let's say goodbye to Shaf and Belzer. Thank you so much.